All right, so this is perhaps one of the most important days in chemistry. We're going to learn how to write ionic formulas. You already got a little feel for it yesterday while we were doing the paper ions. It might actually be easier than doing the paper ions. So, the target that we're focusing in on is you need to be able to understand how these ions are coming together to form ionic formulas, and you need to be able to uh, predict what these ionic formulas are going to look like. All right, what are atoms made up of? Again, what are the two parts of the atom that are the most important? One part is not that important. The two that are the most important. Austin, no, you're halfway right. Protons, I'll accept protons. All right, protons and electrons. Protons are going to give you your identity. So we can identify you by your protons. But the protons don't tell you neither diddly nor squat about what the personality of the element is. That personality is based on its electrons. Let me give you an example because you're beginning to understand how things work. Sodium is this metallic looking, it's almost like you could imagine a metallic Play-Doh, a shiny metal Play-Doh. That's what sodium would look like. It's soft and you can mold it with your fingers if you wanted to touch it with your fingers. Okay? You take out a little piece, squeeze out, pinch out a little piece of that sodium, put it in your mouth. You will feel extreme amount of pain. Then maybe you'll feel a lot of heat, and then maybe just maybe you'll hear a pop and a small explosion, and you'll see teeth and tongue coming out of your mouth. That's how dangerous sodium is. And yet, once it loses its one electron to become sodium plus one, then it's half of salt, which is something that we need in our bodies. Actually, you have a bunch of sodium plus ones running through your bloodstream right now. So, do you think electrons are important? Yeah. You have all your electrons, you can kill somebody. You lose one electron and you are now super safe. You're now super safe. So electrons are very important. When we say that an atom is neutral, what do we mean? However many number of protons we have, that's how many electrons. So if you have 5 positives and 5 negatives, the end result is nothing. You are neutral. 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 So those are atoms. We're not going to deal with atoms often. We will deal with ions. Ions. What are ions? When an atom loses or gains an electron, it is now called an ion. When an atom loses or gains electrons, it is now called an ion. So an ion is an atom that is no longer in its natural state. It has lost or gained electrons. When they gain electrons, they will have a negative charge, negative ion or an anion. Why? Yes. Let me know when you're ready. So why are they negative? Because if you gain negative things, then you're negative. Okay? You are negative. For example, here is chlorine with 11 positives and 11 negatives. What happens if another negative comes around and joins the group? Now you will have 11 positives and 12 negatives. And that's not for chlorine, is it? 18 and 17. 17, 17, 17. So chlorine normally has 17 protons, 17 negatives, electrons. What happens if it gains one? It now has 18 electrons. That's a total of a -1. That's a -1. It has gained an extra electron. Those are called onions. No, they're called anions. Anions. But if you think of onions, you know how onions have little lines on it, then maybe that'll remind you of what to call it. When they lose electrons, they will have a positive charge. They will be called a positive ion, or they'll be called a cation. Cat ion with little pluses for eyes. Why are they positive? Because if they lose a negative thing, like a pimple, then that's a positive thing, isn't it? So sodium normally has 11 positives and 11 negatives. If sodium loses an electron, then it will be 11 positives and 10 negatives. So overall, it has a +1 charge, right? We're good?
Yeah.
Okay. So there is no difference between the name of the element and its cation. So if sodium loses an electron, it's just going to be called sodium. But we do change the name of the anion. What we do is we add an IDE ending. We add an IDE ending. We kind of cut out the way it normally ends and we add IDE. Okay, so give some examples. Chlorine is going to become chloride. What about oxygen? What do you think oxygen is going to become? Oxide. And nitrogen? Nitrogen, no, it's nitride. Nitride. Nice try, yes, nitride.
I tried. Oh my God.
So, if you are sodium and you lose an electron, you're still going to be called sodium. But if you're magnesium and you lose 2 electrons, you're still magnesium. But if you're chlorine and you gain an electron, now you're going to be called chloride. Chloride. How do we know whether a cation will lose 1, or we've even mentioned 2, or in the case of aluminum, 3 electrons, or whether an anion will gain 1, or gain 2, or gain 3, like you saw yesterday in our paper ion thing? Well, you look at your best friends. Who is your best friend? The periodic table. Take it out. Get ready to tattoo your periodic table with information that if it's not there, you're in big poo-poo. So I've asked you, do not write on your periodic table unless I tell you to. I've asked you to do that. After today, if you do not have your own periodic table, and if you do not have this information on there, you're going to be in big trouble. Big trouble.
Diffusion capital. Hold on.
All right. So, what important piece of information can the periodic table tell you easily? Whether an element will become a cation or an anion. That's the first thing that you can tell easily from the periodic table. How can you determine this? Notice that on the right side of the periodic table, there is what I like to call a zigzag line, what Ms. Whitaker likes to call a stair-step line. Do you see it on your periodic table? Go ahead and make it darker. Go ahead and make it darker. We're on the periodic table. The back of the periodic table is the periodic table's butt. We're not there. We're on the periodic table. Look back here if you're confused. Look on this periodic table. The stair-step line is in red. Make sure that you see the stair-step line on your periodic table and that you make it darker. That is the first tattoo that you will use, that you will do on your periodic table. Make it darker. Make the stair-step line darker so that you can see that in order for you to be positive, you have to be on the left side of the zigzag line. For you to be negative, you have to be on the right side of the stair-step line. Anything on the left side, you are a cation. Anything on the right side, you are an anion. Only write down the periodic table what I am asking you to do. That's it. No more. You're going to have to memorize that everything on the left is positive, everything on the right is negative. Leave your periodic tables ready for more tattooing. Plenty of tattooing to do. Now, how can you tell about their charges? Well, copy this down and then I'll show you what to write on your periodic table. Group 1 are called the alkali metals, and they will always be +1. Group 1 will always be +1. Group 2 are called the alkaline metals, and they will always be +2. The next to the last column are called the halogens, and they will always be -1. The ones next to them do not have a name for the whole row, but we know that they are -2s. And then finally, aluminum, gallium, and thallium are +3. +3. You got those? Great. Now, go to your periodic table and write this down. Everything that is in blue or red, not the middle stuff. I'm going to circle what you need to write down. Write that and that. And that, and that, and that, and that, and that. And that, and that, and that, and that. You might want to put a little plus. Ms. Whitaker did not on these. The ones in red are +1s and +2s. Are we good? You got them? IJ, you got them? All right. Let's have some fun. So how do we write ionic formulas? Step number 1, write the symbol of the metal with its positive charge. Step number 2, write the symbol of the non-metal next to the metal with its negative charge. Step number 3, ask yourself the question, are the charges the same? Yes? Done. Rewrite the formula without any of the charges. There should not be any uppy numbers. No uppy numbers. I hate uppy numbers. I hate superscripts. Make sure you get rid of all the charges and write down the answer. If the answer is no, the charges are not the same, you will crisscross. Crisscross. Mr. Marino, what the heck are you talking about? Be patient. Be patient. We're going to do plenty of examples. Plenty of examples. No, Timothy, we will. But we will. The way you're saying it, you're casting doubt. You're saying, sure we will. No, you're not saying, I am sure we will. You're saying, sure we will. All right. Before I teach you the easy way, let me explain to you the concept behind it. So I'll explain for those of you who need to understand the big picture. My wife would be like you. I just need, just tell me what to do. That's me. But some of you are like, no. Explain to me why you're doing what you're doing. For you people, I'll first do it the long way. And for the rest of us, I'll do it the short way. Okay? So, typically, it's always going to be given to you like this. Metal, non-metal. So you look up sodium on the periodic table. I need somebody to tell me the symbol and the charge. The symbol and the charge. I asked you, we memorized these symbols, remember? And I told you, it's important to memorize it so you don't spend too much time looking for them. Carter. No, I need the symbol and the charge. Na, and according to what? No. The charge is going to be the number that we just tattooed on our periodic table today. It should be found on top of the column, +1. All right, who can find for me chlorine and its charge? Chloride. It's been changed, it probably was chlorine. Emily. Cl, -1. All right, so what happens if we get a +1 and a -1 together? What happens in math? They cancel out. So because of that, the answer is NaCl. That's it. Notice what went away. What did it go away? The +1s and the -1s. Why? Because they canceled out. Okay? What else is not there? The little ones. Why? Because ones are understood. Now, let me show you how to do this. So, with the crisscross way, even with the crisscross way, if the charges are equal, you are done. You are done. These are the easiest ones that you will ever encounter. Any questions? All right, let's do the next one. Somebody, potassium, please. Bailey. K +1. Okay. Next, oxide. Oxide. I don't know. Is there There's no element called oxide. It's because the name has been changed to an IDE ending. What is oxide probably the element named for?
Oxygen.
Oxygen.
Oh,
Nathan, can you give me the symbol and the charge? O and -2. Are the charges equal? No. Okay,
No.
so I'm going to teach you the long way. You don't have to do it this way. This is for those of you who enjoy understanding the big picture. Yesterday, remember the little pieces of paper that we had to stack up so they were equal? Okay, if you're a +1, what size would you be? Little. If you're a -2, what size would you be? Medium. So yesterday, it would be something like this. We would have seen something like this, right? Which meant you weren't done yet. Now you're done. So all we did was get rid of the charges and then use our fingers to add them up. 1, 2, K, 2. 1, O. That's the long way to do this. Let me show you the easier way. Watch this. Criss, cross, 2, 1, K, 2, O. See what I did? The 2 gets crossed over and becomes the 2 for the potassium. The 1 gets crossed over and becomes the 1 for the oxygen. And ones are understood. What do you think? Remember, no uppy numbers. Uppy numbers, bad. Let's do more. All right. Who would like to help me with this one from beginning to end? Volunteer. Thank you, Manuel. Barium, symbol, charge. Barium, symbol, charge. No, that's bromine. Okay, let me give you a clue, guys. With these, you need to look on the left side of the zigzag line. They're always going to be there. Go. Ba, charge. Look at the top of the column. What? +2. All right, there is no element called chloride, but there is an element that's close to it. You can tell that they changed it to IDE, so it's what? Cl -1. All right, here we go, because I saw some faces and you were kind of confused. You ready? You ready to crisscross? What's your final answer? Bam. Now, sometimes when people crisscross, they bring the positives and negatives. Do you have any positives and negatives? No. No, all you're doing is you're using this number. The reason why the positives and negatives are there are so that you arrange it in the correct order. It always has to be positive first, negative second. Always. Chemistry doesn't care about your feelings. So if you're sitting there feeling like, no, I think that now I should have the negative first, then that's fine. That is a valid feeling, but that will be marked wrong. In chemistry, we don't care about your feelings. The fact is, it has to be the positive first, the negative second. And the whole reason to have positive and negative there is to make sure that you're arranging it correctly. Aubrey, thank you for volunteering to do the next one. Magnesium, symbol, charge. Brianna. Very good. Sulfur is the next one. Look for it on the right side. Okay. Are the charges equal?
No. Yes.
Then the answer is done. Darren, thank you, sir. Aluminum nitride. Aluminum. Charge. +3. Nitride. Are the charges equal? What's the answer?
What was that on the N3?
All right, back to this side. Osvaldo, aluminum, symbol, charge. Chloride, symbol, charge. Are the charges equal? Crisscross. What? What's the whole purpose for the plus there? To make sure that you are placing them in the correct order. Any questions so far? Okay, these are as hard as they get. You ready? Aluminum oxide. Ariel. Aluminum, symbol, charge. Charge. Oxide, probably oxygen. Crisscross.
Hey, yo.
Okay. What is the whole purpose for these positives and negatives? To make sure you put them in the right order. Once you've put them in the right order, do they matter anymore? No. One more. We'll add this one in. Add it in. Zinc fluoride. Zinc fluoride. Let's see, Carter, go. Symbol, charge. Crisscross. You need the ones.
No.
I hope